Electron affinity. The energy that is absorbed or released during the addition of an electron. Trend for this goes up the group to right of the period. So these would be highest electron affinities. Exceptions would be the noble gases. As you can see, these are unstable. There's a few unstable ones here as well, but we will have a look at that shortly. Now, what does it mean by these electron affinities? Have a look over here. This businessman wants to give an electron to this beryllium. Will beryllium want to take this product and pay money? Well, the same money in the form of energy? Absolutely not, because there was already 2 electrons filled in this subshell here. It's already quite happy and stable, does not want to take that. Same thing with this neon here. Will it take this electron and give money in the form of energy? Absolutely not. It also has a full valence shell depicted here. Next, the fluorine. Will it take this electron from this businessman? Absolutely, because this electron will now enter here. Now it has a full valence shell. It will absolutely give a lot of energy, a lot of money to this person, to this businessman. As you can see, negative 5.4, very large value. By the way, all of these are times 10 to the negative 19 joules, the unit of energy. Next, we have oxygen. Will it take this electron? Absolutely, because now it is one step closer to having a full valence shell as so. So it would absolutely want to give energy. Hence, negative 2.3. As you can see, not as high as fluorine, which makes sense. As you can see, we have carbon, same thing. It will take this electron. Now, as you can see, it's quite stable. Not very, very stable, but stable enough to have a balanced teeter-totter approach with these subshells. Not going to have a full valence shell like these ones, however, still quite happy, so it would absolutely give a lot of energy. So, as you can see, these elements on the left side, they would be saying, you better pay me to consider taking this electron because they definitely do not want it. Now let's have a look at 2 more questions here to end off. What is the significance of an element having a positive electron affinity? Well, let's have a look here at beryllium. If it's completely full, right, is the resulting ion stable or unstable if it takes an electron? Definitely does not want to take it. If you force it to take this electron, it would have a positive electron affinity. It absolutely does not want it, because if it takes it, this whole thing would become unstable. So the answer would be unstable. Last one. Atoms of what group have the most negative electron affinities? These would be the halogens, as you can see with the trend of the group, and we also have the fluorine there have the highest electron affinity. So halogens would be the answer.